as it opens downwards. The fourth is decreasing or the non-increasing function. So if x1 is less than x2, then f of x1 is greater or equal to f of x2. This is similar to the condition for strictly decreasing functions, except there's a equality sign over here. So if x1 is less than x2 and f of x1 is greater or equal to f of x2, then in such a case we say that it is a decreasing function or it is a non-increasing function. So let's try to see it graphically. This is the graph of y equal to fx. Now we see that for this portion this is strictly decreasing. For this portion its value is constant, and for this portion we see that again it is strictly decreasing. So we can write it as this portion as strictly decreasing, this portion as strictly decreasing again, and this portion is constant. So we can say that this is a decreasing function. This is not a strictly decreasing function because of this interval, because for this we see that f of a is equal to f of b. So we can say that it is a strictly decreasing function for values of x which are less than a and for the values of x which are greater than b. And for this interval between a to b we see that it is a constant function. So we can say that for increasing function f dash x should be greater than 0 for increasing function, and f dash x should be less than 0 for decreasing functions. And similarly, if a graph has to be concave upwards, then f double dash x should be greater than 0, and for fx to be concave downwards, f double dash x should be less than 0. This is for upwards and this is for being concave downwards. And if f double dash x is equal to 0, then we say that this is a straight line. Now carefully look at this animation. We see that there's a ball that is moving along this curve. The blue line represents the curve and there's a ball moving along this curve. We also see that there's a bar that is attached to this ball and it is also moving. But we see that for some of the parts it is green in color, for some parts it is red in color, and for some points it turns into black color. Now why does this happen, and what does these different colors represent? I can tell you this bar is nothing but the tangent at any point on this curve. So it's changing its direction as the tangent changes its direction when the ball is moving along different points on this curve. Also we see that the color is changing. For some parts it is green. The green color represents the points for which the slope or the dy by dx is positive. The points for which it is red in color, it represents the points for which dy by dx is negative, and the points at which this is black, then it represents the points where dy by dx is equal to 0. So we say here that green represents dy by dx is positive, red represents dy by dx is negative, and black represents where dy by dx is equal to 0. So we see that where the bar is green in color, it is an increasing part. Where it is red in color, it represents the parts for which fx is decreasing, and the parts for which it is black in color, it represents dy by dx is equal to 0. So enough of theory, let's try to solve an IIT problem. Now this problem appeared in 1999 and it says that the function fx equal to sin x to the power of 4 plus cos x to the power of 4 increases if option number A is x lies between 0 and pi by 8, option number B is x lies between pi by 4 and 3 pi by 8, option number C is x lies between 3 pi by 8 and 5 pi by 8, and option number D is x lies between 5 pi by 8 and 3 pi by 4. So in this problem we have to find the interval of x for which fx equal to sin x to the power of 4 plus cos x to the power of 4 is an increasing function. So let's try to solve this problem. Given that fx equal to sin x to the power of 4 plus cos x to the power of 4. Now we know that for fx to be an increasing function, f dash x should be greater than 0. Now what we do is we differentiate this function with respect to x to get f dash x equal to 4 times sin x cube into cos x plus 4 times cos x cube into minus sin x. We take sin x into cos x as common and get 4 times sin x into cos x into sin square x minus cos square x. Now sin square x minus cos square x is nothing but minus cos 2x. So we write this minus sign here and cos 2x, and this becomes sin 2x. So we get finally as minus 2 into sin 2x into cos 2x. Now again 2 times sin 2x into cos 2x is nothing but sin 4x. Thus we see that f dash x is equal to minus times sin 4x. Now we want f dash x to be greater than 0, and for that sin of 4x should be less than 0. Now we know that sin x is negative in the interval of x lying between pi to 2 pi. So 4x should lie between pi and 2 pi, and hence x lies between pi by 4 to pi by 2. Now we see that if x lies between pi by 4 to pi by 2, fx becomes an increasing function. Now we see that option number B is the subset of this interval, and hence we can say that option number B is correct. Let's try to solve one more problem. This appeared in IIT JEE 1995, and it says that the function fx equal to log of pi plus x divided by log of e plus x is, option number A is increasing on the interval 0 to infinity, option number B is decreasing on the interval 0 to infinity, option number C is increasing on the interval 0 to pi by e, decreasing on the interval pi by e comma infinity, and option number D is decreasing on the interval 0 to pi by e and increasing on the interval pi by e comma infinity. So in this problem we have been given fx and we have to find which of the 4 options is correct. So let's try to solve it again. Given that fx is equal to log of pi plus x divided by log of e plus x. Now we know that in order to find whether a function is increasing or decreasing, we need to find f dash x. So we again differentiate fx with respect to x to get f dash x equal to this very big expression, which is nothing but log of e plus x into 1 by pi plus x minus log of pi plus x into 1 by e plus x whole divided by log of e plus x whole square. Now we have to check whether f dash x is positive or negative. Now if we take positive values of x, then we see that e plus x is less than pi plus x, as the value of pi is greater than e. So 1 by e plus x would be greater than 1 by pi plus x, as e plus x is less than pi plus x. As we see that this quantity is less than this quantity and both are positive, so log of this quantity would be less than log of this quantity, that is log of e plus x is less than log of pi plus x. So we see that first of all this quantity is positive, then this very quantity, this, is less than this quantity, and so we can say that f dash x is less than 0. So we can say that for x in the interval of 0 to infinity, f dash x is less than 0, or we can say that fx is decreasing for x in the interval of 0 to infinity, and hence option number B is correct. I'm sure it's getting very interesting. So let's try to solve one more problem. It appeared in 2001, and it is, if f of x is equal to x into e to the power of x into 1 minus x, then fx is, option number A is increasing in the interval minus 1 by 2 to 1, option number B is decreasing in r, option number C is increasing in r, and option number D is decreasing in the interval minus 1 by 2 to 1. Here r is the set of real numbers. So in this problem again we have been given the function fx and we have to find which of the 4 options is correct. And also all the 4 options are based on the concept whether fx is increasing or decreasing in a particular interval. So fx is equal to x into e to the power of x into 1 minus x. Now what we have to do? Yes, of course, we have to differentiate this function with respect to x to find whether this is increasing or decreasing. So our very first step is differentiation of fx. So f dash x is equal to, we differentiate this function and get e to the power of x into 1 minus x plus x times e to the power of x into 1 minus x into 1 minus 2x. Now I'm pretty sure you have become the master of differentiation. So this becomes a very simple function to differentiate. Now we take e to the power of x into 1 minus x as common and get 1 plus x minus 2x square. Or we take a minus sign here and get minus e to the power of x into 1 minus x into 2x square minus x minus 1. This could be further factorized as x minus 1 into 2x plus 1, and hence we see that the expression f dash x is equal to minus of e to the power of x into 1 minus x will multiplied by x minus 1 into 2x plus 1. Now we know that this expression is always positive, and the expression x minus 1 into 2x plus 1 is positive for the interval minus infinity comma minus 1 by 2 union 1 to infinity, and this expression is negative for minus 1 by 2 comma 1. So we see that f dash x is positive for x in the interval of minus 1 by 2 comma 1. Hence f dash x is positive in this interval, so fx is increasing in the interval minus 1 by 2 comma 1, and this is nothing but option number A. So we can say that option number A is correct. Now let's once again go back to the theory. Next topic is properties of monotonous functions. Till now we have seen what are monotonous functions, what are their different kinds, and how to find whether a function is increasing or decreasing. Now let's try to understand the properties of monotonous functions. The first is, if f and g are two increasing functions, then f plus g is also increasing function. That is, if we have got two functions f and g and both are increasing functions, then the sum of these functions is also an increasing function. Further, if any one of f and g is a strictly increasing function, then f plus g is also a strictly increasing function. So in this part, f and g were just two increasing functions or two non-decreasing functions. But if I say that any of f and g is a strictly increasing function, then the sum of these functions is also strictly increasing function. Similarly, if f and g are decreasing functions, then f plus g is also a decreasing function. That is, if f and g are two decreasing functions, then their sum is also a decreasing function. Further, if any one of f and g is strictly decreasing, then f plus g is also strictly decreasing. So, in short, we can say that if f and g are two increasing or decreasing functions, then the sum is also increasing or decreasing. Further, if any one of f and g is a strictly increasing or a strictly decreasing function, then f plus g is strictly increasing or decreasing respectively. The second important property is, if f of gx or fog x is defined, then if fx is an increasing function and gx is also an increasing function, then fog x is increasing function. If fx is an increasing function and gx is a decreasing function, then fog x is a decreasing function. If fx is a decreasing function and gx is an increasing function, then fog